Welcome back. This is Unit 1, Lesson 6, Metric Conversions. So we're going to be building on from one of the previous videos where we dealt with the metric system. So let's quickly talk about metric conversion. There are lots of different units and we need to be able to convert between them. So as you can see below, I have an acronym kind of spelled out on the bottom showing us how we can move between different prefixes that we can attach to our units. So if you look at KHDUDCM, kilo, hecto, deca, base unit, deci, centi, milli. These are our prefixes we can add onto base units. So like grams, I can have kilograms, hectograms, decagrams, decigrams, centigrams, milligrams. So an acronym that we can try to remember this by is King Henry's Drunken Uncle Drink Chocolate Milk. That's the one I was taught, and that's the one I use, and it sticks to my head even today. So let's go ahead and take a look at our different ways to convert. So a couple of rules. You cannot convert between units that measure different properties. So I cannot convert meters to seconds. They measure two different things. I can, however, combine units to make a complex unit. So like speed would be a complex unit. So if someone travels 10 meters in 5 seconds, right, what is Nadia's speed? So distance divided by time, I would get 2 meters per second. I combined the units there to make a complex unit, meters per second, which is speed. All right, so let's look at our method for converting. It's called dimensional analysis, also called factor label method. You're going to take your given quantity and multiply it by a conversion factor. Your conversion factor is going to be whatever unit you're converting to divided by whatever unit you're converting from. So let's look at an example to hopefully help us clarify exactly how this is going to work. So if we are asked how many liters are in 830 milliliters, notice how I set up and plugged into our formula. My given quantity of 830 milliliters times our conversion factor. Our conversion factor, we're converting 2 liters and from milliliters. So liters are on top, milliliters are on the bottom. So let's look at why I put 1 liter in 1,000 milliliters. So typically, whatever my larger unit is, in this case liters, I'm going to assign a number of 1. And then on the bottom, 1,000 milliliters. So there are 1,000 milliliters in 1 liter. If you look on the front cover in your reference table, they show you the different prefixes. So milli, they give you the prefix, they show you. So I'm going to take that prefix, and because each time I move, it's to the power of 10, I'm going to move an decimal point because the exponent 3 times. So I'm going to get 1,000 milliliters for 1 liter. Then when you plug it in, it's just a little bit easier to do it this way. If I had done it, a different way where I had 1 milliliter and then I had a decimal amount of liters on top, you could do it that way. Just a little more confusing. This way, a little bit simpler, nice kind of non-decimal numbers. So next, we're gonna just multiply. So 830 times 1, and then you're gonna divide by 1,000. Cross out our units. We're left with liters. So we have 0.83 liters. So I want you to go ahead and try these examples. So we have one where we're converting from seconds to milliseconds, and another one where you're converting from milligrams to kilograms. So go ahead and give these a try. All right, so here are your metric prefixes again, which we've seen in a previous video. So remember, all metric prefixes, power of 10. So dimensional analysis can also be used for when we want to convert multiple times, so stacking a conversion factor, if you will. So in an example, it says, how much money will Yoki make if she works 2,400 minutes and gets paid $15 an hour? So the first thing you would have to do is convert your minutes to hours and then do a proportion to get how much money she would make. So we can do this by stacking conversion factors. So I know for 240 minutes, I can put up my sort of proportion conversion factor, if you will. And I know that there are 60 minutes in 1 hour. So then I would have that conversion factor, and then I still need to get to the amount of money. So I would know that there is 1 hour for $15. And then we can go ahead and solve. So we can cross out. Notice they're kind of crossed out, but they're on top of each other. So the minutes cross out, the hours cross out, and we are left with just dollars. So you would just do your math. You would have 2,400 times 1 times 15 divided by 60 times 1. You'll end up with $600. So this is a much more complex one, and you won't see this till a little bit later on in the year and when you get to physics. Most of our problems will be pretty simple. I want you to try this stacked conversion factor dimensional analysis question. So go ahead and give this one a try. All right, our kind of shortcut that doesn't involve the conversion factor is called the staircase or the slide method. So notice I put a number line in front of us: kilo, hecto, deca, base, deci, centi, and milli. So let's say we had an example: convert 10 grams to milligrams. You would locate where your given numbers unit is located on here. So in this case, grams is a base unit, and we want to convert to milligrams. So we're going to count based on sliding how many times we're going to move the decimal point and which direction. So I'm starting here. I'm going to go 1, 2, 3. 3 times to the right. So we're going to find over here where 10 is. Put the decimal point 3 times to the right. And then we'll be able to convert to milligrams. So you'll get 10,000 milligrams. A little bit easier. So go ahead and try this one. You're going to convert 1.234 kilograms to grams using the slide method. That is it for this video. Thank you. Please make sure you wrote down any questions you have, and we will discuss them. Thank you.